Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In this video, we are going to see the serial communication in 8051 microcontroller. Before going to start the serial communication, first of all, we have to know the different types of communication system. Okay, let's see the types of communication system. Generally, there are two types of communication system named as simplex communication system and duplex communication system. What is meant by simplex communication system? Let's see. Here in this diagram we can see here that the sender can transmit its data in only one direction. That means if the data transmission is possible only in one direction, then such type of system is known as the simplex communication system. In this diagram we can see here that the A block can transmit its data towards B only in this direction. B cannot transmit its data towards A. Okay, I hope you all understand the concept here. Here this system is known as the simplex communication system. The example of the simplex communication system is our TV broadcasting or radio broadcasting, etc. In that type of system, the communication performs in or happens in only one direction only. Okay. Now let's see the next type of communication system, duplex communication system. The duplex communication system further divided into two types. First one is half duplex and second one is full duplex. First of all, let's see the half duplex communication system. In half duplex communication system, the data can be transmitted and can be received. That means the transmission and the reception happens in this type of communication system. In this type of system, the data can be flow in both direction, but the condition is that when the transmitter, if this is the transmitter and this is the receiver, when transmitter transmits its data towards the receiver, then at the same time the receiver cannot transmit its data towards transmitter. Okay, when this data transmission is completed, then and then only this receiver block can transmit its data. Okay, this is shown in this animation. Here we can see that A transmits its data towards B, and after complete transmission of this data, B can transmit its data towards A. That means both the process cannot be done at the simultaneously. The example of the half duplex communication system is the walkie-talkie used in the military purposes. I hope you all understand this half duplex communication system. Now let's see the next type of duplex communication system named as full duplex. In this type of communication system, the data can be transmitted and can be received simultaneously on a single channel. Okay, that means on a single channel, A can transmit data, at the same time A can receive data. This type of communication is known as full duplex communication system, and the example of the full duplex communication system is our normal cell phones or the conversation on our telephones, etc. Okay, I hope you all understand the basic types of the communication system. Now let's see the concept of data transmission. Data transmission means transfer of data in the form of bits between two or more digital devices. We know that in digital circuits the data is available in the binary formats, that means in the form of zeros and ones. These zeros and ones are transferred from one place to the another place. This process is known as the data transmission process. The data transmission is further divided into two types: parallel transmission and the serial data transmission. The serial data transmission also has the two types named as synchronous data transmission and the asynchronous data transmission. Okay, now let's see the data transmission types one by one. The first one is parallel data transmission. In parallel data transmission, all the bits of a byte are transmitted simultaneously on a separate line. That means here in this diagram, sending device and receiving device is shown. The sending device has the 8-bit data, hence we use here the 8 separate lines to send these 8-bit data. Okay, that means for each bit we require one single line. This type of transmission is known as parallel data transmission. I hope you all understand the basic concept of the parallel data transmission here. In parallel data transmission, multiple lines or wires are required. Parallel transmission is possible only in short distance communication only. For example, parallel transmission can take place between a computer and its printer. That means the parallel data transmission is not suitable for long distance communication. The reason is that for long distance communication, for 8-bit data, we require 8 separate lines, and which increases the entire cost and complexity of the circuit. Hence, the parallel data transmission is not preferred in the long distance communication. Okay. I hope you all understand why parallel transmission is not used in long distance communication. Let's see the advantages of parallel transmission. In this type of transmission, all the bits are transmitted simultaneously at the same time. Hence, the total time required for the transmission is very less. That is, for 8-bit data transmission, only one clock cycle is required. That means here sending device has the 8-bit data, and the sending device transmits this overall data towards the receiver in only one clock cycle, because for each bit there is a single line is used. Hence, the data transmission is very fast in parallel data transmission. Due to this, the clock frequency can be kept low. The disadvantages of parallel data transmission are: to transmit n bit word, we need n number of wires. That means here we have the 8-bit data, hence we require the 8 lines. If we have 16-bit data, then we require another 8 lines. That means total 16 lines here. If the data is of 13-bit, 32-bit, then we require the total 32-bit parallel lines. Okay, this is the main disadvantage of this type of system. With increase in the number of users, the number of wires increases and it becomes impossible to handle them. This type of transmission is not possible in long distance communication. Okay. Now let's see the next type of communication, serial data transmission. In serial data transmission, all the bits of a byte are transmitted one by one on a single data line. That means here sending device has the 8-bit data, and this 8-bit data is transferred towards the receiver on a single line. How it is possible? The data is transferred bit by bit here. Okay, bit by bit. That means if the data has 01101011, then the LSB goes first. That means this one goes first, then this one goes first, then this 0 goes. In this way the serial data transmission is happen. Okay, the byte to be transmitted is first stored in the shift register. Then these bits are shifted from MSB to LSB bit by bit in synchronization with the clock. For serial data transmission, only one wire or line is needed between the transmitter and the receiver. Here only one wire is used. Hence, for long distance communication, the serial data transmission is preferred. Okay. Hence, long distance communication is possible in serial data transmission. The reason is that between transmitter and the receiver, only a single wire or a single line is used, and which reduces the complexity and the cost of the entire system. Okay. Now let's see the practical serial data transmission. Here in above figure, the transmitter and the receiver both are the computers. That means the transmitter is a computer, also the receiver is a computer. Since the communication within the computer is parallel, it is necessary to convert the parallel data into serial one at the transmitter. That means we know that in PC for the high speed application we use the parallel data transmission. But if the two computers are at long distance from each other, then these two are connected with a single line. That means we use here the serial data transmission, but the data at the transmitter, that means the data at the PC, is of parallel one. Hence we need here parallel to serial converter. The parallel to serial converter converts this parallel data into serial one, and this serial data is transmitted over a single line or wire. And at the receiver is also a computer. At the receiver we require serial to parallel converter to at the receiver. Okay, at the receiver the serial to parallel conversion is required to be performed. I hope you all understand the process here. Now let's see the advantages of the serial transmission. Only one wire or line is required for the transmission. Reduction in cost due to less number of wires are used. And third advantage is that long distance communication is possible. This is the main advantage of the serial data transmission. Let's see the disadvantage of the serial data transmission. The speed of data transfer is very low, as only one bit sent at a time. That means in parallel data transmission for 8-bit data we use 8 separate lines. Okay, that means in only one clock cycle the 8-bit data is transferred from transmitter towards the receiver. But in case of serial data communication only a single wire is used. Hence for 8-bit data transmission we use 8 clock cycles. That means the transmission speed is very low. This is the main disadvantage of the serial data transmission. Okay, the second disadvantage is that to increase the speed of data transfer it is necessary to increase the clock frequency. Okay, now let's see the types of serial data transmission. There are mainly two types of serial data transmission: asynchronous data transmission and synchronous data transmission. Let's see what is meant by asynchronous data transmission. In asynchronous transmission, the transmitter can begin the transmission of the data bytes at any instant of time. That means in asynchronous data transmission, if the data is ready at the transmitter, then the transmitter can transmit it at any instant of time or at any time. Okay, only one byte is sent at a time. After sending one byte, the next byte can be sent after arbitrary time delay. That means if the transmitter has the one byte, then after sending this byte, the transmitter can send the second byte. Between these two bytes, there is some arbitrary time delay is required. The transmitter and the receiver can operate at the different clock frequencies. Okay, there is no synchronization between the transmitter and the receiver. As the data transmission can commence at any time, it becomes difficult for the receiver to understand the instant at which the byte has been transmitted. That means in asynchronous data transmission, the transmitter can transmit its data at any time. Hence, the receiver cannot detect that the whether the data is transmitted at this time or next time. Okay, to help the receiver, the data bytes, the start and stop bits are used along with each data bytes. Here, in transmission, the data byte is kept between the start bit and the stop bit. The start bit is always 0 and the stop bit is always 1. That means in asynchronous data transmission, we require additional 2 bits with our data byte. These 2 bits are start bit and stop bit. The start bit is always 0 and the stop bit is always 1. When receiver detects a start bit, it will set a timer and begins counting bits as they come in. After n bits, the receiver searches the stop bit. The idle time in between the two adjustment data byte is not constant. That means if we have the 8-bit data and the transmitter transmits its data towards the receiver, the receiver accepts first the start bit. Okay, if the receiver got the start bit, that means the first 0, then the receiver starts counting, and after counting 8 bits, the receiver searches for the stop bits, that means the last one. This type of transmission is happening in the asynchronous data transmission. This is the general block diagram of the asynchronous data transmission, in which we can see here that the transmitter and the receiver is connected with a single line, and data is placed on a single line serially, but in this line the data is placed in start bit and stop bit. Okay, the start bit is always 0 and the stop bit is always 1. There is a specific time delay between two data types, and this delay is not constant. Okay, there is one more important point, that the transmitter and the receiver are not synchronized with each other. The transmitter and receiver are not synchronized with each other. Okay. Now see the advantages of the asynchronous data transmission. Synchronization between the transmitter and receiver is not necessary. It is possible to transmit signals from sources having different bit rates. Third advantage is that the transmission can commence as soon as the data byte to be transmitted become available. The fourth advantage is that this mode of transmission is very easy to implement. The fifth advantage is that the entire cost is low and it is effective scheme. Okay. There are some disadvantages of the asynchronous data transmission, such that first one is additional bits called start and stop bits are required to be used. It is difficult to determine the sampling instant, hence the timing error can take place. The third disadvantage is that the start and stop bits and the idle time makes the asynchronous transmission slow. These are the disadvantages of the asynchronous data transmission. Let's see the application of asynchronous data transmission, the connection of the keyboard to the computer. This is the application of the asynchronous data transmission. Now let's see the next type of data transmission or serial data transmission, known as the synchronous data transmission. The synchronous transmission is carried out under the control of common master clock. That means here we require a synchronization between transmitter and receiver. That means transmitter and receiver both should be synchronized with each other. Here the bits which are being transmitted are synchronous to a reference clock. In synchronous data transmission, no start and stop bits are used. This is the main difference between synchronous and asynchronous data transmission. That means in synchronous data transmission, there is no start and stop bit is used. Okay, the data bytes are transmitted as a block in continuous stream of bits. There is an interblock idle time which also filled with idle characters. Okay, the receiver operates at exactly same clock frequency as that of transmitter. Both are synchronized with each other. Flag sequence of a fixed number of bits which is prefixed to each block. Flag is useful to identifying the beginning of the data block. Okay. In this type of transmission, data is transferred in the frames. The frame would contain more than one byte. There is no gap between the successive frame. That means in synchronous data transmission, the data is placed between the frame. Okay, the data is placed between the frame. Here in this frame, the flag indicates that there is a transmission of the data and one frame contains more than one byte. Okay, one more important thing is that there is no gap between two bytes or two successive frames. This is the main advantage over the asynchronous data transmission. This is the general block diagram of synchronous data transmission, in which we can see here that the transmitter and the receiver are connected with a single data line, and on this data line the data is placed in the form of frames. Okay, the data or the data bytes are continuously transferred in a frame. More than one number of bytes can be transferred in a single frame, and there is no delay between two successive frames. Now let's see the advantages of the synchronous data transmission. The first advantage is that the speed of transmission is much higher than that of asynchronous data transmission. The second advantage is that start and stop bits are not required for the transmission. The third advantage is that timing errors are reduced due to synchronization. These are the advantages of the synchronous data transmission. There are some disadvantages of it. The first one is the transmitter and receiver have to operate at the same clock frequency. That means this requires proper synchronization. Okay, whether in case of asynchronous data transmission, the transmitter and the receiver should not be synchronized with each other. Okay, the application of the synchronous data transmission is that the data transfer between one computer to the other computer through a LAN cable. This is the application of the synchronous data transmission. Now, let's see the basic difference between synchronous data transfer and the asynchronous data transfer. In synchronous data transmission, a data transfer method that sends a continuous stream of data to the receiver using a regular timing signals that ensures both transmitter and receiver are synchronized with each other. This is the important word here, the synchronized with each other. In asynchronous data transmission, a data transfer method that sends data from transmitter to receiver with parity bits or start and stop bits in uneven intervals. That means here no synchronization between transmitter and the receiver. Sender and receiver operate on same clock frequency in synchronous data transmission, where sender and receiver operate on different clock frequencies in asynchronous data transmission. The synchronous data transmission is faster than the asynchronous data transmission. In synchronous data transmission, there is no overhead of extra start and stop bits, while in asynchronous data transmission, it uses start and stop bits. In synchronous data transmission, there are no gaps between data flows as a continuous stream. In asynchronous data transmission, there can be a gap between the data, and it is known as the idle time delay or the time delay. In synchronous data transmission, it uses constant time intervals, while in asynchronous data transmission, it uses random or irregular time intervals. The synchronous data transfer used in chat rooms and video conferencing, while the asynchronous data transfer used in emails. This is the basic difference between synchronous data transmission and asynchronous data transmission. I hope you all understand the serial data transmission and the parallel data transmission in the communication system. Thank you.